installation that you see here is entitled Life Object, and it's about biology and architecture. As you can see, it's not natural material, so you might be asking, why is it made of? What is it made of and why? What we did is we took synthetic materials, fibers and matrix, composite materials that we use usually for airplanes, for missiles, for boats, and we treat them in a biological way, as it was biological material, because biological material around us is made of fiber and matrix. Cellulose, collagen in our body or in plants is fiber and matrix. Same goes for these elements that are made for fiber composite, Kevlar for these yellow ones, or fiberglass for the white ones, but we treat them in a very special way. So the idea behind this installation was to try and study a resilient structure of nature, and we took the bird's nest. As architects, obviously, we are interested in a home, a natural home, as the nest is for the bird. Now, what's interesting in the bird's nest is it's made out of practically nothing. It's very, very light elements, found materials, all of them a bit weird and different. And nevertheless, the bird manages to do a form that is coherent, homogeneous, and structural, highly resilient. It is exactly these properties that we start from. As architects, we would be very interested in doing so. So how do we do that? We take and analyze the nest through a CT scan, try to understand how and why is it so resilient, and then transpose it into our synthetic world of architecture to try to do a resilient structure. So what is a resilient structure? A resilient structure is made of very, very light element, like you see here. It's made of a multitude of elements, not of few elements that you can rely on. It's very open for errors. It has variation. All of that we try to do in composite material, and that's why we have to fabricate it in non-traditional way by self-organization. So you can see here, for example, we introduce self-organization in the material, forming it like in form finding and not through a mold. This way it can behave as if it was a biological material with an hierarchical structure. As I was saying, we are trying to work on this scope, a continuous scope of relation between biology and architecture, or the synthetic and the natural. So if this is a biological material, or it behaves as a biological material, we would want it to be alive. And for it to be alive, we need to have movement, intelligence, reaction, and feedback. And that's exactly what we see here in the pores that are integrated within the structure. These pores are based on shape memory material. It's a material that has intelligence. We call them smart material. It's a material that reacts. It has two shapes or two formats, two states where it's fixed and stable. And it can bounce between these states by a stimuli. In this case, shape memory alloys, nitinol, and they open up when given the stimuli to reveal biological material behind them.